In this video, let's practice solving some friction problems. So here's the first one. So you have this block, it weighs 5.4 newtons and it requires a 2.5 Newton force to push it and make it go at a constant velocity, right? So let's start, like we do any of these, with the free body diagram. We know that because this thing's going at a constant velocity, these two forces have to be equal to each other and these two forces have to be equal to each other, right? So if you remember your equations for friction, right, I know that the coefficient of friction is the frictional force divided by the normal force, and if I rearrange that, right, I get the frictional force is equal to the coefficient times the normal force. Okay, so let's see how we would solve this. So we know that the block weighs 5.4 newtons. So if the block weighs 5.4 newtons, that means that it's also going to be the normal force, because we've said that Fg and Fn have to be canceling each other out because there's no net force because it says constant velocity. So I know my normal force is 5.4, and then it tells me that I'm pushing with a force of 2.5 newtons. And again, because these two forces have to cancel each other out because it's going at constant velocity, that means that they have to equal each other, right? So I know my normal force and I know my frictional force. So if I want to get the coefficient, then I just divide the two. And I get my coefficient of kinetic friction as 0.463. Okay, so here's the second part of this problem. It's an extension to it. So now it's saying same block, right? Same coefficient of friction because it's still the same two surfaces touching. But now I add an extra weight on top. So instead of having just one block that I'm pushing, there's a second block on top. And this one has a weight W, right? And I know the one down here below, it was 5.4 newtons. So now I'm trying to figure out, okay, what's the weight of this block that I stuck on top? Okay, so I can figure this out because, again, everything's canceling out because this thing, again, it's being pushed at a constant velocity. So I can say my forces in the x direction are zero, the net force, I should say, and that's equal to the force I push minus the frictional force. Okay, so I know frictional force is mu Fn, so F has to be equal to mu Fn, right? If I move this over and I plug in mu Fn for FF, I end up with this. Okay, and so mu Fn has to be 4.2 because now it's telling me that I pushed with 4.2 newtons, right? So again, because there's not accelerating in this direction, I'm pushing with 4.2, so friction has to be 4.2. And I know that my coefficient from the problem before was 0.463. So if I plug that in, I can divide over, so 4.2 divided by mu equals my normal force. So 4.2 divided by 0.463 gives me 9.07 newtons. So that's my normal force. Okay, so how do I figure out what the weight of that one block is? Well, I know that one of the blocks was 5.4. So 9.07 is going to be equal to 5.4 plus whatever the weight of my second block is. And so if I just move that over and subtract, I get that the weight of the second block is 3.67 newtons. Okay, so here's my third problem. So I've got a crate and I'm applying a force. I'm trying to figure out, is the crate going to accelerate? So again, draw a free body diagram, make it easier to look at. So again, it looks like the one that we did before. So gravity and normal force are canceling out, and this one, the force that I'm pushing forward, if I can make the box accelerate, it will have just overcome this frictional force, right? It'll be a small amount bigger than this one, right? Because if it's at rest, pushing the same won't make it accelerate, but if I push a little bit more, it will, right? So if this is my frictional force is, let's say 300, I have to push like 300.01, like just enough to break it. Okay, so let's start with trying to figure out how much friction is, right? So I need the normal force. So my normal force is going to be 500 newtons because I know that the normal force and the weight have to cancel each other out because obviously the box isn't accelerating up and down. So weight is mass times g, and I'm using 10 for g instead of 9.8. So 50 times 10 is 500. So my normal force is 500. Okay, so if I want to get the frictional force is the coefficient of static friction times the normal force. And so the problem tells me that my coefficient of static friction is 0.25. So my frictional force is going to be 0.25 times my normal force, which was 500. So 0.25 times 500 gives you 125 newtons. So that's the biggest the frictional force can be. So if I push on this side with 100 newtons, that doesn't mean that the frictional force is going to be 125. That wouldn't make any sense. You push and then like the thing pushes back on you, right? That means, what this means, static friction means that this is the maximum force that you have to push to actually break those two things apart and make them start moving across each other. So in this case, if the force of static friction is 125 newtons and you're only pushing 100, the box doesn't accelerate. Okay, so I hope that helped you solve some friction problems. Just remember, always start by drawing a free body diagram because it'll make it easier for you to see everything and the relationships that are showing up.